Right, let's look at a second lens case. We're going to look at a concave lens, draw the ray diagrams, and then again complete it algebraically. 6 centimeter tall object, 11 centimeters away from the concave lens, 4 centimeter focal length. Again, let's just make sure we've got the principal axis, we've got the perpendicular line through the principal axis with the optical center, both focal points, and the object the correct distance away. 6 centimeters tall, 1, 2, 3, 4, 5, 6. 11 centimeters away, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Focal points 4 centimeters on both sides. 1, 2, 3, 4. 1, 2, 3, 4. Once you have that, you're ready to draw your ray diagrams. Now remember, with lenses, the light actually passes through and refracts after passing through. First thing we do, again, I always start with that parallel line. Parallel line will refract, but in this case it won't refract towards the focal point. This type of lens will refract the light as if it came from the focal point on the same side. So again, I'm drawing a dashed line. Because this will bend away, it's going to appear like it came from the focal point on the same side of the object. That's a little different in this case. So it's going to bend away from with this type of mirror. Concave mirrors always have this principle. Notice I'm drawing a dashed line with the focal point on the same side of the object because it'll appear to come from there. Doesn't actually come from there, it'll appear that way. The second line we draw again is right through the optical center because it passes undeflected, so no refraction in this case. And then now that I've got two rays, I can draw the image. Notice because one of those rays is dashed, the image is going to be dashed. This is going to be a virtual image in this case, not a real image. So if we were to describe the characteristics, and I tend to only draw these two rays for concave, they're a little bit different with a concave. The image in this case is going to be erect, meaning it's straight above the principal axis. It's smaller, so it's diminished, and it's virtual because one of the rays is virtual. If we were to find our distances, it's just about 3 centimeters away from the mirror, so I'll say about 2.9 for the distance, and its height is about 1.5 centimeters above the principal axis. So we're going to list those points. It's about 2.9, so it's negative 2.9. Using our sign convention, it's a virtual image, so negative 2.9 centimeters. Its height, we said, was 1.5, and it's positive because it's above the principal axis. Now list everything we know. The height of the object, 6 centimeters. The distance for the object, 11 centimeters. The focal point, because this is a virtual image, it will be negative 4 centimeters. Be careful with that sign. It's a virtual image. And we're going to find DI and HI and M. Notice our calculations algebraically are going to be the same for the two mirror and the two lens formulas. It's just a simple formula. I'm really worried about you putting in the proper signs for virtual and real images. Start with the formula. 1 over F equals 1 over di plus 1 over do. Again, manipulate for di. So 1 over di equals 1 over f minus 1 over do. Make sure you put the appropriate sign in. 1 over negative 4, that's the biggie, minus 1 over 11. And again, punch it in, then reciprocal the answer. So 1 divided by negative 4, subtract 1 divided by 11, x to the negative 1, you should get 2.93 centimeters, and it should be negative. It's a virtual image. So negative 2.9, we were right on with that one. Now use the magnification formula, HI, HO, negative DI, DO, manipulate for HI, negative DI, HO over DO, put your numbers in. DI was 2.9, HO was 6, DO was 11. Since this image was erect, we should end up with a height of the image as being positive. And again, the two negative signs make this positive. So 2.9 times 6 divided by 11 gives us 1.58. So we can say it's about 1.6 centimeters, pretty close. And notice the signs work out based on our ray diagram. That's why I always recommend drawing the ray diagram. I have some graph paper inside the Unit 1 extra materials for you. You could print off lots of graph paper to draw these ray diagrams. Highly recommended, because then you can see that your algebra makes sense when you do this. And again, to do the magnification, HI, HO, use the graphical answers, 1.5 over 6 gives you 0.25 times, and do the algebraic one, 1.6 over 6, 0.27 times. And it should be a number less than 1 because the image is smaller in this case. Magnifications greater than 1 will give us larger images. Magnifications less than 1 will give us smaller images.